So we're going to factor by grouping. Make two groups. 2a squared plus 3a space plus 6a plus 9. You know what? I want to pause it and give you guys some time, see if you guys could give me the right answer. Go for it. So as we continue here, after making the two groups, you want to factor out the GCF from each group. So of course, you look at your first group and you think, is there anything in common? Well, there's a 2 here, there's a 3 here. Wait a minute. There's nothing in common with the coefficients. So is there anything in common? Well, yeah, you have a squared here and 1a here. So the maximum amount of a's you could pull out from both at the same time is a single a. So let's pull out an a. And if we do pull out an a, what's going to be left over? 2a plus 3. That's right. Now let's look at our second group. And there's an a here, but there's no a over here. But what is in common? A 3. That's right. So let's pull out a 3. And not only that, I want to make it a positive 3 that I pull out. And what would be left in there? 2a plus 3. Okay, and now if we look at step 3, it says factor out what's in common, the binomial, from both groups. So we have our first group, we have our second group, we have the same exact binomial, 2a plus 3, that we're going to pull out. So normally when I explain this in front of you guys, I say take a step back and pull out what's in common in both groups, which is the 2a plus 3. So all I've done is taken the red binomial 2a plus 3 and the red binomial 2a plus 3, and I pulled them out, and now it's out here in the front. So if I did pull this out, what would be left? Just an a. And if I did pull this 2a plus 3 out, what would be left? The 3. Now, of course, these parentheses are exaggerated. Let's write them in the correct size. And there is your final factored form of the above quadratic polynomial. Let's try one more. Okay, guys, number 8. 12a squared minus 15ab minus 16a minus 20b. Is there a GCF in all 4 terms? 12, 15, 16, 20. You're probably thinking you can pull out a 2, but you can't pull out a 2 from here. You can't even pull out a 3 because 16 doesn't work with 3, or 20 doesn't work with 3. So you got to go and try once again factoring by grouping. Factoring by grouping, let's make two groups. Let's make some space between the first 2 and the second 2. So that was step 1, make two groups. I just made some space between the 2. Step 2 says factor out the GCF from each group. So I'm going to look at my first group and what's in common, especially with the coefficient 12 and 15. What's in common?
8.
No, I'm talking about 12, the number 12 and the number 15.
Oh.
3, right? There's 3. So for sure, I could pull out a 3, and in addition to the number 3, I also have a squared and an a, which means I could pull out a maximum of 1a. So the 3 is going to actually be a 3a. That's the GCF for the first group. And if I did pull out 3a, what would be left over in that first parenthesis right there? 4a minus 5. B. Excellent. Whoa. The second group, what could you pull out? A 4. Now, check this out. Check this out, guys. This is very important. When we pull out, if you're saying to pull out a positive 4, what would be left on the inside? A negative 4a and a positive 5b. Now notice that this binomial is not identical to this binomial. As a matter of fact, they're complete opposites. So what's my remedy? I need these guys to have their sign changed. So let me go back to this, erase this, and let me actually change this positive 4 that I factored out. Let me make it a negative 4 that I'm factoring out. Now why is that? Because if I pull out a negative 4 times what gets you a negative 16a? That would be positive 4a, right? And then negative 4 times what gets us a positive 20b? That'd be a negative 5b. So do we see that in this case, it was important that we pulled out a negative 4 instead of a positive 4, because when you pull out a negative, you really do get the same exact binomial 4a minus 5b. So now it's time for step 3, where you take a step back and you pull out what's in common in the first group and the second group. So what is in common in the first group and the second group? You have the binomial 4a minus 5b on both. So let me pull out the 4a minus 5b. 4a minus 5b. And what would be left on the inside of the parentheses? 3a minus 4. Of course, let's write them with the correct size parentheses. There's your final answer, your final factored form. And if you were to distribute it, 4a times 3a, that's 12a squared. 4a times negative 4, that's negative 16a. Negative 5b times 3a, that's negative 15ab. And negative 5b times negative 4, that's positive 20b. Let's move on to something different. Let's move on to solving equations with the zero product property. So in order to understand that, we first need to answer the question, number 9 right here. Describe in your own words what the zero product property is. What is a zero product property? The zero product property is when you're multiplying two terms and your answer is 0, either the first term could be 0 or the second term could be 0, which means that you could technically split it and say A could be 0 and B could be 0, or both. And if you solve both, you get two simple equations. Guys, the zero product property will come in handy on these equations, 10, 11, 12, 13. Now, why does it come in handy? Because on number 10, this is actually in factored form already. So you already have something times something equals 0. That means that the first something, 4b, could be equal to 0. Or the second something, b plus 4, could be equal to 0. This is applying the zero product property when solving an equation. Now, why is it that easy? Because it's already in factored form. So it would be ridiculous for you to distribute. Don't do that. It's already in factored form. All you're doing is splitting it. So 4b equals 0. If you divide by 4 and divide by 4, b still equals 0. That's one answer. Over here, subtract 4, b equals negative 4. That's another answer. So you actually have two answers for number 10. This is applying the zero product property. Once again, the zero product property is when you have something times something equals 0, your first something could be 0 and your second something could be 0. So all you're doing is taking this and splitting them, setting them each equal to 0. And ultimately what you're doing with the zero product property is taking a complicated looking equation, because if you were to distribute, that'd be a quadratic trinomial equation. You're taking a complicated looking equation and breaking it down to two simple equations because of the zero product property. So you split them with the zero product property. Now you're going to solve. So you're going to subtract 6. You're going to have the answer A equals negative 6. There you go. And the other one, you're going to add 7. You're going to have 3a equals 7. You're going to finally divide by 3. So the answer is A equals 7/3. It's okay to leave it as an improper fraction. Those are your two answers to this problem number 11. So as you can see, if they're in factored form, it's as easy as just splitting them and solving the two easy equations. If we take a look at number 12, that one's also factored already. Okay? So when you split them, you get those two easy equations. So the equation on the left, if you subtract 8 and subtract 8, you're going to end up with 4y equals negative 8. And then if you divide by 4 and divide by 4, you're going to end up with y equals negative 2. So on this last one, or on the next one, we're going to add 4 to both sides. Of course, the 4's cancel. You end up with 3y equals 4. And the final step would be to divide by 3. So your y equals 4/3. Y equals 4/3. So ladies and gentlemen, we have two answers for number 12. And like I said, it's really easy because it's already in factored form. All you got to do is split them and solve. Now if you look at number 13, number 13 is not in factored form. Okay, so this is where factoring kicks in. On the left side of this equal sign, you have a binomial. You have two terms. Let's always try to factor out the GCF first before any other factoring method. So what's the GCF on the left side of this equal sign? 4. So there is definitely a 4 in common, but there's something else. There's a P. There's 2 P's right here. There's 1 P right here. We're going to pull out a maximum of 1 P from both terms at the same time. So the 4 is also with the P. That's the GCF, 4P. Now what's going to be left on the inside of the parenthesis, you still have the equal 0 over here, but what's going to be left on the inside of the parenthesis, help me out here, what's left on the inside? 2P minus 1. Perfect. And now we have it in factored form. Now we could say, okay, now I really have something times something equals 0. So that means that my first something, 4P, that could equal 0. Or my second something, 2P minus 1, that could also equal 0. And now I could solve both. On the left equation, 4P equals 0. We know that if we divide by 4, 0 divided by 4 is still 0. So P equals 0. The other one, let's add 1, plus 1 here, plus 1 there. You're going to end up with 2P equals 1. Final step would be to divide by 2, which means that P equals 1/2. P equals 1/2. So we have those two answers for number 13. What do you think? That's when the left side of the equation is not factored. You have to factor it first. Why do we factor? So we could get something times something equals 0. That way we could split it using the zero product property and solve both easy equations. Let's move on to number 14 right here. Now number 14, if you're thinking of using the zero product property, you can't even use it because it's not equal to 0. So what you need to do first is set it equal to 0. You want to move your 15x from one side to the other so it could actually say equals 0. So what's my first step here? You're going to subtract 15x. And you're going to subtract 15x. Now, that doesn't equal 3x. You can't really subtract 18x squared with 15x because they're not like terms. So the only thing you could do is rewrite it. So you're going to have 18x squared minus 15x equals 0. Now the whole purpose of moving it over is so you could get this equals 0 part. Because if you have an equals 0, and then if you were to factor, you'll be able to use the zero product property. So let's try to factor. What's the GCF when you look at this quadratic binomial on the left-hand side? There's definitely a 3, but there's something else besides the 3. There's also an x. Excellent. So what would be left if I pull out a 3x from both terms? 6x minus 5. Perfect. And now we truly have something times something equals 0, which means that we could split them. So you'll have 3x equals 0, and you'll have 6x minus 5 equals 0, and you could solve both. We already know that this guy, when you divide by 3, it's still going to be 0, so x equals 0. That's one answer. The other one, when you add 5 and add 5, you'll have 6x equals 5, and if you divide by 6 on both sides, you're going to end up with x equals 5/6, and that's another answer for that one. Let's try this last question, number 15, right here. I'm going to give you time to do it. I'm going to pause it, and then we'll jump to the answers. So obviously, we want to set it equal to 0. You're going to add 26x to both sides. You can't really add it to the left side. You're just going to rewrite it. So now we do have the equation equal to 0. So now we're going to pull out the GCF of both terms, which is what? 2x is the GCF. And if we pull out what's the 2x, what's left? 4x plus 13 is what's left inside. So now we're going to use the zero product property to split them and solve. Whoa. So we're going to split them and solve. So there it is, 2x equals 0, 4x plus 13 equals 0. Let's solve both. Divide by 2 on both sides on the left equation. You're going to get x equals 0. And on the right side, subtract 13 on both sides. And you'll get 4x equals negative 13. Divide by 4 and you will get x. I ran out of space. X equals negative 13 over 4. Both of those are your answers to this equation.